This is AP Calculus 3.3, derivatives of inverse functions. So in the last segment we reviewed what an inverse function was. Now we're going to talk about how to find the derivative of inverse functions. And this is an application of the chain rule. Because we know from our knowledge in Algebra 2 and in pre-calculus, if f and g are inverse functions, then the composite function g of f of x has to equal x. Then if we're trying to find the derivative of that inverse function, if we take the derivative of this function, we're going to do the derivative of the left side and set it equal to the derivative of the right side and see what happens. See what the derivative of that inverse function is. Well, since this is an application of the chain rule, you have a function within a function. When we learned the chain rule, we learned that when we take the derivative of a function within a function, we take the derivative of the outside function first, so that's g prime of f of x, and then we multiply that times the derivative of the inside function, that's f prime of x. And then on the other side, if we take the derivative of x, we just have 1. So if we're trying to figure out what f prime of x is, f prime of x would be equal to 1 over g prime of f of x. So this is a demonstration in symbols of the derivative of an inverse function. If we're putting that to use in an application, here it says let f of x equal e to the x. The inverse of f of x is g of x. And we know from previous knowledge that the inverse of e to the x is natural log of x. What we're going to do here is we're going to find f prime of x and g prime of x. We're going to find the derivatives of those two functions that we know to be inverses. And then we're going to look and see, does this formula that we just derived work? So f prime of x, the derivative of f, the function f is e to the x. We know that the derivative of e to the x is e to the x times the derivative of the x, or 1. We know that the derivative of its inverse, natural log of x, is the derivative of the x part over the original. So now what we're going to do is we're going to plug this information in to see if these two things are in fact equal to each other. So f prime of x is e to the x. We have 1 over g prime of f of x. Well, f of x was e to the x. So if we're trying to plug in here, we know that g prime of x is 1 over x. So if we're looking for g prime of e to the x, we're going to plug e to the x into the g prime function. So that would be 1 over e to the x. Well, then we can invert and multiply and see that when we do that, we do end up with what we started with. E to the x does equal e to the x. So in the last example, we were just showing that two functions were inverses and that derivative formula for the derivative of inverse functions did work. This is how it will be applied to actual functions within your calculus curriculum. Here they say let g and f be inverses. So we know they're telling us g and f are inverse functions. They give us an ordered pair for the f function. F of 2 equals 21. Well, doesn't that mean that in the f function we have the ordered pair 2, 21? Now, just with our knowledge of what inverse functions are, if in f of x we have an ordered pair 2, 21, and we know that g of x is the inverse of f of x, then don't we know that g of x has an inverse point, 21, 2? Or in other words, don't we know that g of 21 has to be equal to 2 in that inverse function? So we're using that information, that ordered pair, to find an ordered pair in the g function. Then they're asking us to find g prime of 21. Well, we know g of 21 is 2. They want us to find g prime of 21. And then they give us the f function is 2x cubed plus 3x minus 1. Now, it might be tempting to try to find the inverse of the f function, g of x. But there's no way we can do that with our knowledge of functions in algebra, just because if we switch the x and the y, well, we're going to end up with two y's there. There's not going to be a way to get the y by itself and get one concise function. So we can't do that here. So we have to rely on our knowledge of knowing that g prime of x is equal to 1 over f prime of g of x to find the derivative of g prime of x. So to solve this, let's just talk about what we know. We know that f of g of x is equal to x because they tell us g and f are inverses. So if they ask me to find g prime of 21, I need to work with this equation so that I can get g prime of x alone. So that's what I'm going to do first. I'm going to take the derivative of each side. So when I do that, I use the chain rule here. The derivative of f of g of x is f prime of g of x times g prime of x. We take the derivative of the outside function and multiply it by the derivative of the inside function. So those two are multiplied together. The derivative of x, the other side, is just 1. So if I'm trying to find g prime of x, I can then get g prime of x by itself, and that would be f prime of g of x. So they're asking me to find g prime of 21. Well, if they want g prime of 21, couldn't I just plug 21 in for every x that I see here? Well, if I do that, because function notation tells us if we're trying to find g prime of something, and we know that's what g prime equals, well, g prime of that something of 21 means if I replace this x with 21, all I have to do is replace all these x's with 21. Well, there's only one to replace it with. So then I can just simplify what I've got here. We know that g of 21 is equal to 2. We found that with the ordered pair that they gave us at the beginning. So g of 21 is equal to 2. So that means that's 1 over f prime of 2, because g of 21 is 2. So now let's talk about f prime of 2. Well, we don't know what f prime of 2 is, but we do know what f is. We know what that function is. So couldn't I take the derivative of f, get its derivative, and then plug 2 into the derivative to find f prime of 2? That's what we would do here. So f prime of x is 6x squared plus 3. So that means f prime of 2 is 6 times 4 plus 3, which is 24 plus 3, or 27. So f prime of 2 we know is 27. So we have 1 over 27. G prime of 21 is equal to 1 over 27. And anytime you're given inverse functions to find the derivative of, this is the method I would use. If they give you an ordered pair, you know how to find an inverse ordered pair by flipping them, switching the x and the y. And then you can usually, by doing the chain rule, you'll get enough information here to be able to plug things in one thing at a time to find what they're asking you to find. Here's another chain rule problem. They tell us in the given that f and g are inverses. They tell us that f of x is equal to negative 2x cubed minus x plus 8, and f of 0 equals 8. They want us to find g prime of 8. Well, just looking at what we have here, if f of 0 is 8, wouldn't g of 8 be equal to 0? So that's going to be a bit of information that we will use later. If we know f and g are inverses, we know that f of g of x equals x. So if we take the derivative of both sides, we're going to do the chain rule. the derivative of this side, we take the derivative of the outside function, multiply by the inside function, that's the chain rule, that equals 1. So we know that g prime of x is equal to 1 over f prime of g of x. They're asking us to find, I'll write it up here, g prime of 8. Well, if we've replaced this x with 8, all we have to do is replace this x with the same number, 8, the same x value. So we know g prime of 8 is equal to 1 over f prime of g of 8. From our knowledge of the ordered pairs, we know g of 8 is equal to 0. And then we need to find f prime of 0. F prime is negative 6x squared minus 1. So if I plug 0 in to that function, I get negative 1. So g prime of 8 is equal to negative 1. In this example, they're telling us that the table is giving us select values for f and f prime. They're telling us that g of x is equal to the inverse of x. So they're telling us g and f are inverses. And they're asking us to find g prime of 2. So we're going to set this one up very similar, but now instead of having an equation to take the derivative of, they've given us different ordered pairs to use. So we know that since f and g are inverses, f of g of x has to be equal to x. So if I find the derivative of each side, I would use the chain rule on the left, and the derivative of x is just 1. They are asking us to find g prime of 2. So I'm going to get g prime of x by itself. And if they're asking for g prime of 2, well, that means if I've replaced this x with 2, I'm going to replace all the x's over here with 2. So I've got 1 over f prime of g of 2. If I'm trying to replace g of 2, we know that f of negative 5 has to be equal to 2. So g of 2 will equal negative 5. So if I replace this g of 2 with negative 5, then all I have to do is find f prime of negative 5. F prime of negative 5 is 7. So g prime of 2 is equal to 1 over 7. And that would be our answer for that problem. This problem is very similar to the last. They're telling us that the tables give us select values for f and f prime. They tell us that g of x is equal to the inverse of x. So that means g and f are inverses. They want to know what is g prime of 10. So if f and g are inverses, we know that f of g of x has to be equal to x. So if I take the derivative of both sides, I would have f prime of g of x times g prime of x equals 1. So g prime of x equals 1 over f prime of g of x. They're asking us to find g prime of 10. So that means I'm going to replace this x with 10. So what I need to find is g of 10. Well, if the x value of the g function is 10, wouldn't that mean I need to figure out what x value for x gives me a y value of 10, since they are inverses? So I'm going to go to my f of x, find the g value, or the f of x value equals 10. The x value when that happens is 3. So f of 3 equals 10. So that means g of 10 must equal 3. So g of 10 equals 3. That means I have 1 over f prime of 3. I go back to my table. I find f prime for 3. That would be 9. So my answer is 1/9.